At this time, I would like to welcome Dr. Michael Bailey to the stage for his keynote presentation, A Security Practitioner's Guide to Internet Measurement. Dr. Bailey is currently a professor and school chair in the School of Cybersecurity and Privacy at the Georgia Institute of Technology and has over 20 years experience in both corporate and nonprofit arenas. Since his first in-person attendance at NANOG 26 in Eugene, Oregon, Dr. Bailey has contributed several talks at NANOG on security and networking, most recently at NANOG 57 on IPv6 adoption. Welcome, Dr. Bailey.
Thank you. So I was going to actually, you're not supposed to wear your NANOG shirt from this year. So I was going to wear my 26, but at this point, the 26 looks a little ratty. So I figured I'd go with something more collared. So welcome everybody to Atlanta. I just recently moved here myself. And I'm going to start by talking a little bit before we get started about how I got from where I was, which is the University of Illinois, to here. So I don't think it's going to come as a surprise to anybody in this room that there's a variety of security, availability, reliability challenges that we're currently facing as a global society. Any number of examples pop to mind from the last 12 months, whether it's the current conflict between Ukraine and Russia, in which the kinetic war on the ground, tanks, planes, guns, has been in parallel seeing huge amounts of activity in the cyberspace world and in really unexpected and unusual ways. We had last year the second biggest crypto hack ever, $600 million. So I like to talk about this as like GDP level theft. Like literally there are 10 countries in the world in which this is greater than their GDP. We had a ransomware attack in Costa Rica that basically shut down the government. The new incoming president of Costa Rica actually declared a state of emergency because of the loss of services that occurred via the ransomware. And of course, somewhat closer to home, we saw attacks against email hosting and email hosting provider in the last quarter of 2022. And we had folks like the CEO of Cisco, and this was a couple years ago, talking about in order to address this need, we have to drastically increase the number of people that care about security, availability, and reliability in our information technology networks. Basically, the idea that we only have half as many people as we need. We could double the number of security practitioners and still not meet the needs that we have in terms of society. So when Georgia Tech, which is where I'm from here in Atlanta, or where I'm here from now, called up at Illinois, and they said, we're trying to do a new thing. You should come to Georgia Tech. And I'm like, pretty happy at Illinois. I've enjoyed a nice career there. But they're saying, look, we're going to do something fundamentally different here. We're going to create an academic department exclusively for cybersecurity and privacy. Now, for those of you, and I was checking the distributions, and I know it fluctuates from time to time, but there's not a lot of my academic colleagues here. But, academic departments are things like physics, chemistry, biology, right? Things like cybersecurity, at least at most universities, are virtual institutes. They're spun up. People have home departments in computing or math and statistics, and we do something, as a virtual mechanism to bring them together to solve societal problems, but then 10 years later, we get rid of it. When you make an academic unit, this is an acknowledgement that this domain, this problem is not going away. This is no longer a 5-year, 10-year horizon problem. This is a permanent problem. And so when they pitched me this, I said, okay, you know what, sold. I'm in. Okay, let's go do this. And their vision, of course, has been an interesting one because it's a societal problem. It's not exclusively a technical one. So I'm a technical person. I have my PhD in computer science. All the jobs I've had have been of the computing variety between now, from when I graduated. But this department has lawyers. It has public policy people in it. It has international affairs folks. It has people that do psychology and cognitive science in it. Because, of course, it's not exclusively a technical problem. So I interviewed. It went well. And, of course, I'm here. So I've been here for about 9 months. And I'm just getting used to the kinds of things you're experiencing today, which is that it was 32 degrees this morning and it will now be 70 degrees by the time we leave this afternoon. But certainly, I'll take that over the snow in Ann Arbor and in Illinois. So certainly you could say, given my career, that I'd sort of drank the Kool-Aid, right? I'm a security person. I'm here. That's how I enter the world. That's how I live and breathe. But it wasn't until I got to Georgia Tech that somebody had called me a zealot for the first time. So let me tell you a little bit about how I got to a place as a department chair where somebody is talking about a career or an ideology that sort of dominates the personality. So in order to understand, and as I said before, I didn't see a lot of academic colleagues, so let me explain what a department chair is. You know what the Dilbert cartoons are? I would hope so at this place, right? Like, get it? Yeah, the pointy-haired boss, that's middle management. That's the equivalent for a department chair. There's provosts, there's chancellors, there's deans, people that cut ribbons and build buildings, and then there's department chairs that deal with who's going to teach what class when, the complaints for the students. It's basically a middle management job. Okay? And so when I try to think about how I could explain this kind of version of middle management to the NANA crowd, one example came to mind. So assume you're this guy. Okay, and I don't know how many of you know who this is, but assuming this guy, and this is 2003, so what's that, 20 years ago, right? And you're at NANA 2003, you're on a panel explaining how you built a Python thing that looks a lot like Splunk, so you can ingest all the alerts that come off of your network. You just got introduced by Randy, who's here in the corner, and already 20 years ago, Randy started this panel by saying, well, it used to be the case at Nanog that everybody touched a router. For those of you that still do, ... Okay? And so, obviously, Danny at this point is doing things, right? He's talking about things he's building. He has operational responsibilities. Heck, he's so good at it, he writes a book about the kinds of things that you can do when you talk about BGP in the network. And then fast forward to 20 years later, and the guy's got a suit on with the full Oxford tie thing. And yes, I know what that is now, which makes me scared too. And he's got some, executive vice president title. And they're giving him awards for papers he wrote 18, 20 years ago. Okay? So this is kind of what it feels like to me to walk from being a person who, used to play with data and build graphs and write papers to be pushed into a management position. So when the opportunity arose to connect with my research roots, to meet with students, to engage in research opportunities, you can understand why I sort of grabbed it immediately. So somebody walked up to me and said, hey, look, there's a network reading group that meets every Wednesday. We have free pizza. We talk about the papers that we're working on. And I'm like, I'm in. Like, if I'm going to find 1 hour to do something that's not pushing paper and email around, I'm going to absolutely do this. And of course, there was free pizza. And I don't know, I'm a grown person. I get a salary. I can afford my own meals. But something about the grad student in me, if somebody offers me free pizza, I'm there. Okay? So it was a great opportunity to sort of reconnect with where I had been and sort of pretend at least that I was still a technical person at heart. Okay? And I got to see some cool stuff. So last week's project was that a research faculty member came in and talked to the students about this LoRa sensor deployment they have in Savannah, Georgia. Okay? So it turns out flooding is a thing when you live on the coast. And it turns out whether or not it floods or not floods not only has to do with measuring the storm surge of some hurricane that's making its way up the coast, but it has a lot to do with tides and the way that the watershed is engineered in the building around a city. So what these guys have done in combination with the local authorities, the county and the city and the state, is they deployed a bunch of water level monitoring sensors, right, throughout the floodplain, so that they can actually build better models. They could do incident response instead of predict that this storm surge is actually going to result in flooding. All kinds of really cool and interesting stuff. And I'm like, wow, okay, this is LoRa. Somebody actually deployed it, right? There's these boxes with these little tiny batteries that they change once a year, right? With base stations that they talk back to and cloud backend services. Like, I'm getting all geeked about it. So exactly what I was hoping to have happen, okay? Connecting to interesting things that matter. Well, one of the activities that we had in this sort of graduate student seminar is a networking activity. So, we should all go meet each other and shake each other's hands and sit down and talk. So I got paired up with, and I'm not going to say who it is because it's local. So I got paired up with somebody in the room, and so we started talking about who I am and what I do and where I came from and my ideas and philosophy about how you do this kind of network measurement. And because it was, a month ago and Nanog was coming up, the topic of Nanog came up, and I got really excited and animated because I love Nanog, and there's a bunch of the stuff that I've done that we've been able to present here and hopefully have some kind of measurable impact on. And of course, as important as explaining what Nanog is and what people do, you have to explain things that are like free pizza. The only thing better than free pizza, of course, is free beer. So we talk about beer and gear, and this is a great place you should definitely go when it's here. And so I start talking a little bit about some of the work that we've done in this context because I'm excited to share it with the student. So as I was going back over my career, looking at my CV, the very first little itsy-bitsy bit of academic work I did was back in Nanog 23, 2001. Okay? I wasn't in graduate school at that point, wasn't even really a researcher at that point, but I was blessed to interact with Craig Labovitz, who was at Merit Networks, and Abba Ahuja. And I know many of you remember Abba fondly as well. She later came to work for me when we were at Arbor, and we're all, of course, very sad that she's no longer with us. So one of the pieces of work that was really led by Craig and Abba, but I got to participate in a little bit, was at the time they were exploring this, what might seem obvious now, but radical notion that, hey, look, the internet's not fully connected. Like, it is literally the case that there are places in the internet that you can't get to, and other places that can't get to you. Okay, and so this graph here is the pairwise failed connectivity. So what we see is roughly 5,000 networks at the time that can't reach some other network that is reachable by other people, right? It's not like they're offline, right? Other people can get to it, you can't. Now, this was sort of surprising at the time. There were others like Ripe had just started to think about this problem as well, but this was a really surprising result. And this kind of thing got me really turned on to this idea that there's really interesting problems happening on the internet. The next piece of work that we presented at Nanog was 3 years later in 2004. We built something called the Internet Motion Sensor. So 2004, for those of you who remember the Wayback Machine, this is the, we'll say emergence, although they existed before. This is worm time. Okay, this is all the worms, right? And while they were real things before this, this is when they're making the cover of the New York Times, and people are talking about hundreds of millions or billions of dollars in damage and cleanup. Okay, and so what we had done was a lot of network telescope work. These are low interaction honeypots. You grab up a big piece of unused, allocated, routed, but unused address space, and you just basically watch all the packets that go to it. And if somebody's scanning, if somebody's trying to enumerate places that they can attack, you can watch them do that enumeration. And one of the things that was really interesting about this particular piece of work at this time was this bottom bar chart graph, which is that the way that we used to do this, because there used to be a time in the internet when there were /8s laying around that you could use. I realize that I'm talking about IPv4 here, right? No longer the case, of course, but you could just announce an entire /8 and just route all the packets to it and see what people were doing. Well, one of the interesting observations about this particular piece of work was it actually mattered where you did the sensing. So what you see in the bar chart in the bottom is the different magnitudes of traffic that we're seeing at similarly sized pieces of darknet. Right, so where you are matters. You can't just have one big telescope now. You need to have telescopes everywhere. And this is one of the things that we had thought about in building a distributed telescope. Okay, fast forward 7 more years. We're still thinking about unused address space and what it means. In this particular paper, we looked at evaluating background radiation, these sort of packets that go, whether it's scanning or misconfiguration, to this unused address space. And what was interesting about this particular study is we're getting now close to the point where we're actually running out of addresses in IPv4. So one of the interesting things that was being asked as a question at this point was, hey, look, who gets the last bit of IPv4 address space? And are all addresses considered equal? Okay, and so one of the arguments that people were making is, yeah, don't give me 1/8, right? Because 1/8's a mess. Okay, so what do? Well, we go work with the RIRs and we announce, so they get the allocation. We announce it for a couple weeks and see how much of a mess it is. Well, it turns out 1/8 in particular is in fact a great big mess, right? At least at that time, right? And so if you need some insight as to why 1/8 is a mess, consider that it includes 1.1.1.1 and other really important addresses like 1.2.3.4. Okay, so you imagine that people go to their Cisco routing book and they start typing into routers in their basement, configurations that are in the book, and all of a sudden you can imagine the way we see things. And we see huge order of magnitude. So here's 35/8. This is a darknet that we had been measuring for 5 or 10 years at this point. And here's 1/8. Not even the protocol distributions are the same, let alone the magnitudes, right? So this resulted in some recommendations for policies about how we're going to do allocation and what blocks we should withhold, which blocks we should go off and give. Okay. A couple years later, because of course we got interested in this idea of address exhaustion and scarcity, well, what do you move to? Obviously, you're moving to IPv6. Now we're still moving to IPv6. 10 years ago, we were moving towards it. 10 years before that, we were moving towards it. So this was a sort of a snapshot at moving towards IPv6. I did notice that you can connect to the IPv6 only wireless for Nanog. So this is like one of the places where that's awesome. But one of the things that we were struggling with is this idea of, I know this is just sort of Janus philosophy, about the blind people that are touching different parts of the elephant. And it matters whether or not you're touching the ears or the trunk or the legs about what you're actually seeing. Right? What we found was there was huge 2 orders of magnitude difference in your view of what adoption was. How good things were going really depended on who you were. And so in this particular graph, you're looking at the ratio of IPv4 to IPv6 for allocation, for advertisement in the routing tables, for server readiness, data from Google, actual traffic over NetFlow at the time we got from Arbor, glue records for .com, for DNS data. Again, what your perspective was drastically influenced what you thought was happening. So then we moved on just the next year and looked at this notion of IPv6 background radiation. So this is the time in the world we thought, heck, nobody's going to scan 6, right? Right? Because, address enumeration and the size of the address space is just not going to work. And of course, we've learned a lot since then. And so this is a real thing now. But at the time we said, hey, look, to even catch anybody scanning, you'd have to have incredibly wide visibility. So basically, we got the permission to announce the covering prefixes for all the /12s. So for a brief period of time, we had the covering prefixes for basically everything that had been routed in IPv6. Okay, and looked at what you got. Now, presumably, you would imagine that all you get is this lower right-hand corner, which is the spaces that are allocated but unused, right? Would correspond to a traditional darknet. In fact, what we found is that 95% of the traffic we saw had nothing to do with what we thought we were going to go see. So it gave us visibility in the upper left-hand corner, to all kinds of routing instability, right? At the time, IPv6 was way less stable than IPv4 was. It uncovered bad filtering properties for networks leaking out internal routes and internal addresses. We saw some weird things, and I have to say, this is researchers doing bad things on the internet, okay? But it was insightful about where we were and where we were going. And then the last piece of work I shared with them was this more recent work in Nanog 65. I think Manish talked about our joint work at that Nanog. And this idea that it's actually possible to predict bad network behavior. So we had a series of papers that try to correlate mismanagement of your network with bad things happening. Mismanagement, whether you're the source of a DDoS attack or amplification attacks, whether you go onto a block list, versus, do you patch your web servers and how fast do you do that? The culmination of that work was actually a set of techniques that allowed us to accurately predict data breaches. Okay? And if you ask, it's a really, really interesting piece of work. I think Manish, who was one of the co-authors, and Ming Yang went off to create Quadmetrics, which then was sold to FICO. I still get a royalty check because I'm on those patents at some point, but I didn't join them. But it was really, really interesting that you could predict these things. It wasn't just random. And you could go look at the paper if you're interested in it, but the single biggest factor was not how vulnerable your systems were, it was how proactive you were. So how quickly would you move from a vulnerable state to an unvulnerable state? Single biggest predictor. Do you have process? Do you know when something's busted? And do you react quickly to fix it? Okay? So I went through this whole thing. I'm super excited. Probably not as animated because I couldn't walk around in that room, but like super excited like I am now. And I said, well, what do you think? And the person turned to me, sort of nodded their head a little, bobbed up and down a little bit, and said, oh, you're one of those people. And I'm like, okay, no, I'm an academic, right? So there isn't a day that goes by without somebody poking fun at me a little bit, and probably justifiably so. So I've got a pretty thick skin. I'm like, well, what do you mean by that? It's like, oh, you're a hacker. You're in the cult of security. And so just like that, I became a hacker and a zealot. Okay. And it is somewhat ironic that this is in fact actually my headphones, and I do own a hoodie. So I mean, I'm aware, right? So I want to talk a little bit about this notion of this cult of security, and I think what they meant by it. And again, I got my free pizza. I went back to the office. I didn't really think about it until I got home that day and was out walking the dog. But something about that comment really stuck with me. It was that I had tried to explain my approach to thinking about all these important societal problems, about measuring things that matter. And what they took away from it was not the measurement, was not the impact of what had happened, but this sort of philosophy of, breaking things, okay? And I wanted to know why they got that impression from what I said and how I could better convey what it is that I thought that I should have been saying. Okay, so I spent some time thinking about this notion of the cult of security. And as I explained to you that I'm not in a cult, I am absolutely aware of the irony of me trying to justify, no, we're not a cult, it's okay. I wasn't recruited, I volunteered. All right, so when I think about what they probably queued up when they thought about what we were doing, was this sort of notion of a security mindset or adversarial thinking. So this is a big deal in the security space. In fact, when I teach intro to security to undergraduates and graduates, like the third slide says adversarial mindset on it. Okay, so we think this way. And it's this idea that good engineering involves thinking about how things can be made to work, where the security mindset involves thinking about how things can be made to fail. This idea that you walk into any given situation and instantly are looking at, okay, so I didn't have my badge. Somebody asked me for my badge when I walked in to get the free coffee. How could I have walked in to get the free coffee without a badge? Right? Like you immediately go in every social situation, what process could I follow? And this is sort of echoed by some thoughts from Fred as well. Adversarial thinking, same sort of mindset as the security mindset, can be seen as the very essence of game theory. Right? Actions by players, they're completely specified. And for cybersecurity, this is all about identifying, you're playing chess, right? There's a bad guy, there's a good guy, and you're playing a game together, right? And the game is all about undermining what they're trying to do. So, if you think about, it's a very compelling way to think about things, right? Because we don't typically approach problems in an adversarial way, and it does kind of highlight a little bit about what makes security people tick, right? They are, in fact, about questioning assumptions. But when you play this as a game, right? When it's a game that you're playing, it sort of results in this sort of nihilist kind of view of the world, right? It's an open game, right? It's not a closed game. You are never going to be secure. The attacker is never going to stop. So the game only ends when one of the players resigns and walks away. right? So it sort of gets this sort of very fatalistic attitude, like, okay, there's another attack. Okay, we'll patch it. Okay, we'll move on, right? And I think this is the wrong idea that you're supposed to get from this notion of adversarial thinking and the security mindset. And I was reminded of this article I had read a while ago, just skimming through my news feed on dark reading, about a security architect at Akamai calling themselves a recovering cynic with respect to cybersecurity. And I remember this paragraph that stood out for me because they talked about the roots of the words skeptic and cynic. And I thought this was really, it sort of struck a nerve for me, right? The Greek root for cynic is dog-like. You are, in fact, a zealot, right? Deterministic, you're an ideologue, you have a specific worldview, and are, doubtful that will ever change. Whereas skepticism, which is I think what we really try to talk about when we talk about a real security mindset, is about inquiry and doubt, right? You don't hold a worldview, you question what's happening with an idea to understand. So if we recast what this notion of a security mindset is, to mean inquiry and doubt and critical thinking, we get something that looks a lot more like the Socratic method for questioning. And I don't know how many of you have had kids, like this pops up, like I get some version of this in worksheets from my kids when they're all grown up now, but used to get these kinds of things from home. Like you have to ask these questions about some idea and let's practice on mom and dad. But they were a set of questions that helped you think about what was being talked about and come to an understanding of what it was. Now, you can see that number 3 is probe assumptions. Probe assumptions is essentially what underlies most of security in this sort of traditional notion of an adversarial mindset. You designed a system, you had a date box, you never thought somebody was going to put in a Julian date or a negative number or a Unicode character. You made an assumption about what the user was going to do with the inputs, and the hacker was there to violate that assumption. Okay? But there's good questions in this sort of notion or framework for reasoning. Why are you asking the question in the first place? What unique perspectives or biases are you bringing in asking that question? Yes, questioning the assumptions as well, but then asking questions about, well, what does it mean? If I actually knew the answer to the thing that we were talking about, what would that imply and why would that matter? Right? And all those things are way broader than this notion of playing a game of chess with an adversary. So I like this definition that comes from IEEE and ACM a little bit better of adversarial thinking. It's a thinking process that considers potential actions of an opposing force working against your desired result. And while I think that captures a little bit of those questions, I think the piece is missing is captured by something that we're talking about in computing right now called responsible computing. Okay, and so this is an effort that's happening at Brown, which I'm really, really impressed with it, and one that I want to see start to be implemented in our own unique way here in Georgia Tech. Okay, this idea that technology is not value neutral. When we build things, we embody the things we build with our own biases about the way the world works and the way that the world should work. And we bear responsibility for thinking about it at what we design. Okay? We should be sure that we're building things with everybody in mind and understand that it's our responsibility if something breaks. So these two things together, this notion of a kind of inquiry, a way of critical thinking that's broader than just questioning assumptions and playing this sort of almost US courtroom style adversarial way to get at the truth, but really about joint understanding, as well as understanding and encompassing the biases that we bring and the consequences of the decisions we make, is how I think about this notion of security mindset. If it turns out that that's a cult, I'm happy to be the guy that's the zealot preaching it. Okay. So let's talk a little bit about that particular worldview and how that worldview can help us in what we do all here today. So all of us in this room are here to make the world a better place for some version and some definition of a better place, right? NANOG's mission statement, dedicated to the ongoing advancement of open, secure, and robust internet. Right? You look at ICANN, secure, stable, and interoperable. You look at something like the Internet Society, a global technology infrastructure, a resource to enrich people's lives, and a force for good in our society. Okay, these are the mission statements of the people that we voluntarily associate with, that are in charge of the governance of the internet of the thing we build. Just at the most recent IGF, which is the UN body that likes to talk about all things internet, the Secretary General was there and talked about the challenges of the current internet, and those challenges undermining democracy, human rights, and science, and that those challenges are outpacing our ability to design and think about them in meaningful ways. So the challenge is a real one. So where do we start? Well, like in the abstract of my talk, I'm a data guy. So I think all understanding starts with data. Okay, at least understanding of people, orgs, societies, even the technology we build. Okay, so in God we trust, all others have to prove something to me using data. Okay, and I like this quote as well from Lord Kelvin. So this is Sir William Thomson. He was the first Baron of Kelvin. The Kelvin temperature scale, and absolute zero, is named in honor of this person. But in one of his early pieces of work, he says, I often say that when you measure what you are speaking about and can express it in numbers, you know something about the thing. But when you cannot measure it, when you cannot express it in numbers, your knowledge is meager and of an unsatisfactory kind. So it all starts, this understanding of what we're doing starts with collecting data and measurement. Now, of course, it's not all about data. I don't want to belabor this point, but for 20 years we've been talking about this sort of knowledge pyramid that we start with data, and from data we get information into knowledge, into wisdom. I will say understanding, because I'm not a very wise person. And of course, it's not really just a filtering mechanism. It's not just like, okay, I start with a pile of data, and then I will abstract it to a pile of information, and from that I will glean some rules that look like knowledge. No, it's obviously a process, right? The kind of understanding that's embodied by the Socratic questions is a process of contextualizing that data, information, and knowledge into a way that makes us be able to do something about it, to act on it in a way that allows us to meet those goals that we had on the previous pages. Okay? And when we don't do this the right way, when we don't think about this with a security mindset, with a sense of inquiry and responsibility, we know we get mistakes. And some of the mistakes are pretty straightforward. There was just a blog post on APNIC about some data about IPv6 adoption in Bahrain, and it stuck out that Bahrain was 100% IPv6 adoption, and all the data that the person was showing supported that the data wasn't wrong, but the perspective was wrong. Right? So there was something about what was happening there, right, that didn't pass that person's sniff test. Right? They questioned whether that could be true based on what they knew, and they provided other evidence to suggest that what was happening wasn't true. Okay? Where we see this stuff play out in really deep and meaningful ways are things like speed tests and broadband. So if we're talking about this notion of access and equity and building things for all people, this is a hot topic right now. Like, are people filtering? Does everybody have the same kind of access that they need from something like the internet? And so these questions can be really, really, really nuanced, right? Do you measure it at the home network, right, at the router, or do you measure from some browser? Like, there's a lot of studies that say that the actual problem is between your laptop and the wireless router, not in the last mile of the ISP for some people, right? There could be impaired ISP links. There's issues with ISP access availability. There could be middle boxes. There could be rate limiting. There could be cheating. There's a whole wide ecosystem of things we have to consider if we're going to not only understand what's really happening for these broadband links, and then more importantly, use that understanding to influence policy. US government policy about how to provide access, and countries that don't have the same kind of access that we do. And of course, all these challenges, mismeasurement, or the need for sophisticated and reliable data for real policy, are happening at a time in which our world's getting way more complex. So I love this paper from last year, 2 years ago, 21, right, at IMC, the Internet Measurement Conference, that they looked at the corpuses of RFCs that were coming out of IETF, as well as all the email on the mailing lists, and they made some sort of stark observations. That the standardization process is taking longer, and the standards that are produced are more complex. That while it's not a stated goal of the process, there are communities of people who are not accurately represented proportionately to the number of people that they have. Okay? That there are companies like Huawei and Google who have become increasingly more influential in that process, while other companies like Microsoft and I can't remember the other one that they listed out are diminishing in influence in the process. And that the complexity of even just authorship is growing. So in a world that's getting more and more complex, in which the standards are getting more and more complex, right, this stuff is really, really important. So there's a variety of different stakeholders that play roles in this ecosystem, whether they're states, whether they're the private sector and civil society and users, whether they're the technical and academic communities, international organizations. I want to cover just a few of these things very, very quickly to give you a sense of where I would love to see more call to action and more critical thinking and use of responsible computing. So there's a lot of challenges. We talked about one of them that might be the result of policy within an individual nation state. One of the ones that I think is most interesting coming out of the academic community is this work by Casey Claffey at CADA and David Clark at MIT, calling for more support of just collecting the data in the first place. If you're going to go start making policies about the way things work, you should actually know how they work first. And step one, and I'm grateful that they start doing this, there's a number of folks that have rotated, say, through the FCC, for example, who have some technological clue in places where they can influence policymakers, but you need to start with the data. So we need to have some commitment to collect the data. And whether that's because we have questions and policy questions, as the second bullet talks about, which are about access, or whether it's simply about acknowledging that things like the certificate ecosystem, routing, and DNS just simply have to work in order for the internet to survive. In the private sector, why should you care? I think this should be fairly obvious. Most of you measure things in some form or another, if for no other reason than to bill people for it, right? But if you go back to these manifestos of why we should measure from 20 years ago, it's a pretty straightforward value proposition. You want to know how much it costs to deploy the thing you're about to deploy. And because you've done this over and over again, you know that no idea of how it's going to work is ever going to survive contact with actual users. And when you deploy, it's going to break other stuff. Right? So if you want to figure out how much it costs, you want to figure out how the users are going to stress it, and you want to make sure it doesn't break anything else, maybe you should start by measuring things. And there's a variety of different measurement topics that you see pop up in the NANOG mailing lists and the working groups, everything from IPv6 to satellite communications, IoT, events like what's happening in the current conflict in Ukraine, Starlink, what happened as the result of COVID-19, modifications to DNS, QUIC, and its impact on our networks, et cetera, et cetera, et cetera, et cetera. And all of them fall in this sort of category. Would you like to know what is it going to cost? How's it going to play nice with other things that I'm doing right now? And is it actually going to work when it's there? And of course, we see situations where we're really stressed, where this isn't just about, I want to deploy the new hot thing that comes from Cisco or Juniper, where we actually have a commitment to make things work and work in the right way. If you haven't looked at this before, this is a report that came out after 9/11 that talked about how the telecommunications infrastructure was stressed as the result of that event. Okay, and it talks about the need for us to collect more data, to share that data, and think about it together so that we can respond to these kinds of events. Users care about things that users care about. They care about, are you doing the right thing? They want to know that what's happening is in their best interest, that it's whatever is happening is fair, accountable, transparent. You see these in the rules and regulations the FCC is trying to put out. They care about their own health and well-being. These things shouldn't surprise you because in addition to being, ISPs and members of the networking community, are also, members of the civil society as well. Okay, in academia, this kind of adversarial thinking about measurement has led to a whole host of papers that talk about how we do measurement better. What are some techniques, some ways, some things that we should be doing and not doing when we measure things? We've been talking about the need for different kinds of visibility. In fact, the IMR call for the National Science Foundation, this is where we get a lot of our money as academics to do things, is all about this idea that the internet's changed, that we do a good job of measuring the core, right? But the way that people access the network is fundamentally changed. Where we don't have the visibility is in the access layers, right? We need to be thinking more about wireless. We need to be thinking more about, and then in the application space, we need to be thinking about the cloud providers and how they play. We don't necessarily need, although there's certainly challenges in making things work at 100 gig, right? We don't need more measurement at the core. We need it at the access, and we need it at the sources of the information in the cloud providers. One of the things that I'm passionate about and spending a lot of time thinking about is building models to teach adversarial thinking to our undergraduate and graduate students. So if this is such an important thing, if I'm advocating to you that this notion of inquiry and responsibility should undermine what we do, I better be teaching everybody that graduates from Georgia Tech these kinds of things as well. And there's some interesting creative models thinking about this, and some early work, again, from our friends at Brown, that show that it's possible to teach this notion of adversarial thinking even when people don't know the technology. That because it has an artifact in responsibility and critical thinking, you could teach this to high schoolers before they know what a buffer overflow is, right? Because it's being approached with a system, a set of goals, and asking those sets of questions. So in the last few minutes, I just want to talk about some places where I think that this is starting to take hold, and we're doing good things like this in our networks. So certainly I want to call out to my friends at CADA. You've seen KC and a lot of the folks from CADA out all the time talking about how to take measurements and what those measurements mean. Increasing those conversations are not just how do I get a better AS topology graph, but what does it mean when something is more or less connected? And what would that imply for us in society? There are new public-private partnerships that are starting to emerge, things like MLab, where you see academics working with NGOs, working with providers like Google to start to create public data sets that can be used exclusively, not exclusively, but whose design it is to be used for answering important public policy questions. Big fan of the MAPRG group in IETF. If you go look at their meeting minutes and you look at sort of the list of things that scroll by that they're interested in, it is an amazing snapshot of this intersection between things that are real problems and sort of technology that's being deployed, and academics and practitioners that are trying to measure and get a handle on it. Okay, it's not like this community doesn't think about these problems. You can see plenty of good examples. I think our friends at RIPE do awesome work. I'm a big fan of Jeff. Jeff's been data-centric for a very, very long time. And that's sort of I say infested, but bubbled up into APNIC. And so you look at the blog, if you just do a tag on measurement in their blog, lots of really interesting kinds of questions of the vein that I think we're talking about here. Okay, there are even things that are starting to bubble up to the societies that are in charge of internet governance, like ISOC, where they're starting to ask questions about outages, about IPv6. I think their IPv6 World Day stuff is a great example of us thinking critically about those kinds of problems. And of course, it'd be remiss if I didn't say I'm trying to practice those kinds of things ourselves. One of our most recent papers is about looking at the impact of turning on DNS over HTTPS, and the idea that if you turned on DNS over HTTPS, there's a huge swath of places, the red-colored geographic regions in this particular graph, whose speeds will be slower as the result of turning this stuff on. So this idea that, just turning it on, everybody will be happier is not true, and it comes because of some of the bias that we have for some of our measurements. So that's where I want to stop for today. I hope that I've tried, some small amount of trying to convince you that, critical thinking, questions about premises and assumptions, about evidence and perspectives, and about the consequences of what we do can lead to the kind of goals that we share here at places like NANA, like a more open, secure, and robust internet. So thank you. I think we have 1 minute and 1 second for questions, or I can just step down.
How you doing? My name is Antoine Ostabrook with A2D. As an open access fiber carrier, we're trying to form partnerships with universities as well as solution providers to try to figure out ways that we can make our network better for the coming applications. What would be your advice as far as being able to reach out and make those initiatives?
I can tell you that academics are dying to get real data. This is always the case. So you could certainly talk to me. I mentioned several other organizations. The MLab people, I'm sure, would be open to partnerships. I absolutely know for a fact that CADA would. They've been building those kinds of partnerships for a very long time. So I'm happy to chat with you afterwards as well and connect you with some of those people. But it's absolutely a need. We're used to, I've got a departmental access router, and I've got packet taps with IRBs and everything else on those things. That's nothing like what you have access to. And all the interesting action is not in the head of the curve, it's in the fifth nine. So we need things at scale in order to see the real interesting stuff that's happening. So people are dying for it.
Excellent.
Absolutely.
All right.
John Kemper, Amateur Radio, Digital Communications, 44Net. One of your slides mentioned adversarial machine learning, and I'm interested to hear about what are some of the things going on in cybersecurity to address bias in data.
Yeah, I mean, this is a huge thing. Actually, there's a great talk by, I don't want to plug my boss too much because he's already, the dean of the College of Computing, Charles Isbell, is a machine learning person, and he just gave the keynote talk at NeurIPS, I believe, with a gentleman from Brown who talks about responsible computing. And they're having all these conversations about one of the most powerful things that I've heard him describe is that when we talk about bias in the machine learning community, we often sort of brush it aside as saying that's a data set problem. Okay, so you see these apocryphal stories about the cameras from Southeast Asia that don't see white people because they were only trained on people with Asian faces, right? Or you hear about the generative AIs that only make white people, even if you ask them for people from of an African origin, right? And people will just say, "Oh, that's just a data problem. If you trained it on better data, you'd actually get it to work." And it turns out, if you train it on better data, many of the cases, it still doesn't work, right? Because the process of selecting the machine learning algorithm in the first place, because it didn't occur to you to select appropriate non-biased data in the first place, when you selected the algorithms, when you selected the meta parameters, you could take that algorithm and train it on an exclusively, say, for example, we're talking about the case of generating faces, right? And you want to get a more diverse set of faces. You could train it on all people from Africa, and it doesn't work the right way, right? Because even the selection of the algorithm itself was biased by the things that you started to do. So there's some really interesting kinds of things there. And it's not just a data problem. It's not just, hey, if you think about it more and do the right data, it will go away. No, like the math is broken because of the biases as well. And that sort of struck me as a thing that just sort of blew my mind when I saw the data that showed it.
Thank you.
Yeah.
Hello, Lai Yi from Measurement Lab. So thank you so much for the shout out. And just wanted to say, sorry, everyone here is taller than me. Just wanted to say, would love to meet you if you're interested in collaborating, if you're interested in publishing your data in the open for use in public policy and across different industries. And question for you too. So in that work of trying to connect, data to public interest, a lot of the challenge is in the translation between the technical and the sort of real world applications. And I think you did a great job here with your talk, but just wondering what your recommendations are for technologists trying to make their work more applicable to the real world.
Well, so we're just trying ourselves to understand this, but one of the main reasons that I moved from Illinois to Georgia Tech is that when we built this new department, so first of all, again, they put, when an academic unit, right? We do teaching, research, and service, the only three things that a university does. And so when they tell you you're an academic unit, that means that you're in their core business now. You're not some sort of virtual thing that they're spinning up. You do the thing that they sell, right? So that was, and that's the motivation I gave. The other thing I didn't really talk about a lot, which is your question, is the reason I came is it's a multidisciplinary unit. I have cognitive science and psychology people. I've got economics people. I've got political scientists, I've got public policy people, I've got lawyers, right? 2/3 of my faculty have CS degrees. I've got people with JDs, right? And the reason we do is because to bridge that gap, the gap you're talking about is huge, right? And what I've been profoundly impacted with is that, we come to this technology with such a huge bias, right? When I see the studies that the social scientists do, I'm like, I can do that because I know how to do that and I know how to do that with real data. But the real problem is not that I could have run the study, is that it wouldn't have occurred to me to ask the question in the first place. And even if it had occurred to me to ask the question that the public policy people are asking, I wouldn't have known what to do with the answer once I got it. Right? So this is one of the things that's so huge. And I don't know the answer because I've been there for 9 months, but I'm starting to develop an appreciation for how big the gap is that you're talking about.
Mm-hmm. Mm-hmm. Thank you.
All right, thank you very much.